Hi, welcome to L4M. In the previous video, Plane Geometry 12.1, if you remember, we learned a height of a triangle and we stated that all three heights of a triangle intersect at one point. In this video, we will see how those three heights intersect. Where is that point of intersection of the heights located according to the type of the angle, according to their angles, because when we classify triangles according to their angles, we have three types of angles: acute angle triangle, right triangle, and obtuse triangle, right? Obtuse angle triangle. So we will see where these heights, three heights, intersect at these three different types of triangles. Let's start with acute triangle. You know that acute triangle means a triangle whose each angle is an acute angle, which means less than 90 degrees. So in fact, the example I gave in the previous video uh, to show you that three heights of a triangle are intersecting at one point, this can demonstrate our case for acute angle triangle. When I apologize. Okay, sorry. So when our triangle is an acute triangle, all three heights intersect at a point which is located in interior region inside the triangle. Okay, so in this case, conclusion: in an acute angle triangle, all three heights intersect at a point which is located in interior region of the triangle. Okay, that's the case when our triangle is acute triangle. What happens if we have a right triangle? You know, right triangle is a triangle whose one angle is 90 degrees. Uh, you all know, I believe, that why just one angle can be 90. Two more than one angle cannot be 90 degrees in a triangle. So let's say that we have a right triangle, A, B, C, and let's say that this angle is 90 degrees. Okay. Here, if I want to draw the height from vertex A to the line containing the opposite side, which is BC, you see that that height is has been already drawn. So the leg AB is also the height of the triangle. It's because it's perpendicular. It's the perpendicular drawn from A to the line of opposite side BC. So the leg AB is also the height from vertex A to the line BC, right? What about the height drawn from vertex B, to the opposite side? That's the hypotenuse of our right triangle. Let me use a different color for this one. So that height is here. Let me use H for this point. BH is the height from the vertex B to the opposite side, actually to the line containing the opposite side, hypotenuse AC to AC. What about the third height? Third height is the one which is drawn from the vertex C to the line of which contains the opposite side. Opposite side for C, it's AB, but that perpendicular, you know that the perpendicular from a point to a line is unique. So there's only one perpendicular can be drawn from a point to a line, and that's again, that has already been drawn again. The leg CB of the triangle, the side CB of the triangle, is perpendicular to AB. So CB is a leg. It's also the one of the heights of the triangle from C to AB. So the leg BC or CB, let's write CB, is also the height from C to AB. So we see that actually when I drew the second height, which was BH, it was understandable that the first height AB and the second height BH, they were intersecting at point B here. You see that the third height CB also passes through B, so they intersect at this point. This point is the vertex of the triangle where we have the right angle, right? So that's the conclusion. So for a right triangle, all three heights of a right triangle intersect at the point which is the vertex of 90-degree angle. 90-degree angle. So this time, this point is one of the vertex of the triangle where we have the 90-degree angle. Remember that for acute angle, that point was inside the triangle. It was in interior region. All three heights, let's add here, of an acute triangle. It's better, of course, to write it once more. Okay, let's see the last case. I see that video is already long. Let's leave it to the next video. Please subscribe our channel and stay with us. See you in the next video to see heights of an obtuse triangle.